Hi everyone, this is Omkar from Edureka, and today I'll be speaking about cross-site scripting attacks. So first, let's look at the agenda for today's session. Firstly, I'll be explaining you what cross-site scripting is, the definition, and a brief about what cross-site scripting attack is. Then I'll be explaining how cross-site scripting attack works. I'll be explaining the logic behind this attack. Then I'll be explaining the different types of cross-site scripting attack, and I'll be showing you a demo on how to use cross-site scripting attack to hack a web application. And finally, I'll be telling you how to prevent cross-site scripting attacks. So let's move on to the first topic, that is, what is cross-site scripting attack? Cross-site scripting attack is basically a code injection attack executed on the client side of the web application. The client side of a web application is usually the software that is used to interact with the web application, and in most cases, it is the browser that is used to interact with the web application. So in cross-site scripting attack, we inject a malicious code onto the web browser to make the web application do something that is ideally not supposed to do. So in this case, in this attack, the attacker injects the malicious script through the web browser. And what happens is this malicious script executes on the web application after it's injected on the web browser. The malicious script is executed either when the victim visits the web page or the web server. Now, like I told you, there are different types of cross-site scripting. Depending on what kind of cross-site scripting is being used, the malicious script executes when the victim visits the web page, a single web page, or maybe the web browser. This attack is mainly used to steal sensitive information like cookies, session tokens, and maybe other sensitive information, maybe if you're passing your username or password, and using this malicious script, using cross-site scripting, those information can be stolen from the web browser or the web server. Cross-site scripting can also be used to modify the contents of the website. Because cross-site scripting attack is a code injection attack, you can modify the contents of the website by injecting malicious code onto the web server or the web browser. Now this is a brief about cross-site scripting. Now let's see how cross-site scripting actually works. Let's see what's the logic behind this attack. Cross-site scripting is basically a web application hacking technique. So you need a website, you need a web server, and a victim. So what happens when you ideally access a website? So you have your laptop and then you use the internet connection to access a web page, and maybe you interacted, maybe you send data to the web application, maybe you enter your data in the text box, or even if you don't, there is some transaction of data that's happening between you and the web server through the website. So what happens is you send a request to the web server through the website, and then the response from the web server is sent back to you through the web page or the website. Now what happens in cross-site scripting attack is a hacker can inject a malicious code on the website, which is then sent either to the victim or to the web server depending on what kind of cross-site scripting you're using. And when this happens, the malicious script is executed either when the victim visits a web page or when the victim tries to access a page or access some data from the web server. And when all this is happening, a hacker can inject a code which can be used to steal the credentials or any sensitive information. And by this logic, a hacker can inject a malicious script that can be used to steal the credentials or any other sensitive information of the victim, either from the web browser or the web server. So this is the logic behind cross-site scripting attack. Now let's look at the different types of cross-site scripting attacks. There are mainly three types of cross-site scripting attack. One is the reflected cross-site scripting, and also cross-site scripting is also known as XSS. That's the abbreviation for it. So the first type is reflected. In this case, the data is not stored on the web server. The next type is a DOM, which makes use of the document object model to inject the malicious script. And the third type is the stored cross-site scripting. In this case, the malicious script is stored on the web server. So I'll be explaining these types in detail in the next slides when I'm telling you how to hack each of these kind. So let's move on and see how you can use cross-site scripting attack to hack a web application. Now, like I told you earlier, there are three types of cross-site scripting attacks, and I'll be showing you how to hack each of them. So the first type would be reflected cross-site scripting. So in this type of attack, the script is executed on the victim side, and it is mainly executed on the browser. So the script is not sent to the server, or even if it's sent, depending on the API calls or the requests, the script is not stored on the browser side. And that's why it's called reflected cross-site scripting, because the malicious script is reflected on the victim side and it's not really stored on the server. Now let's see how to hack a web application using reflected cross-site scripting. I'm using damn vulnerable web application to show you these demos. So if you don't know what this is or how to install and configure it, I have a video on how to install damn vulnerable web application. Go through it, install it on your system, and then you can practice different hacking techniques on this. So here I've chosen a reflected cross-site scripting attack. Now let's see how this works. Here's a text box where I have to enter my name and then hit a submit button. So let me just enter some value and see how this web application is designed to work. I'll be entering my name and I'll hit the submit button. So I can see that this web application or this website is designed to echo my name on the website. So what happens is when I enter a name and the web page takes the input and prints hello and the input that was given by me. Now, as you can see, I cannot really modify a lot, but I have total control over what input I can give in the text box. So this is the place where I'll be injecting my code. So what I'm gonna do is I'm gonna type a HTML code. I'll use a h1 tag first, which is used to mention the headers, and I'll type something and I'll close the tag. So this is the code used to display something in h1 tag. So let me just submit. And if this web application is vulnerable to reflected cross-site scripting, you should see a different output. So let me just hit the submit button. So here you can see that the output is modified because I've used the h1 tag. The way that my input is displayed on the web application is different, and this clearly indicates that this web application is vulnerable to cross-site scripting attacks. Now let me give some malicious script here. So I'll be typing script. This is the tag to execute any script, and I'll be creating a pop-up to display something, and let me just hit the submit button. And if this works, you should see a pop-up that says hello. And yeah, you did see a pop-up that says hello. So this clearly means that this web application is vulnerable to reflected cross-site scripting. Now you might be thinking, how is this hacking a web application? Just because I inject a code that displays the content in a different way, it's not really hacking, right? So let me tell you how this can be dangerous. So instead of displaying something in a different way, I'll try to get some sensitive information from this web application. And what I'm gonna do is use the script tag and create a pop-up, but instead of printing a string, I'll try to access the cookies for this web application or for this user basically. So let me just hit the submit button. And here you can see that the session ID is displayed. And using this session ID, I can log into a different account even if I don't know the username and password for that account. Now, what is a session ID? Basically, a session ID is a unique string assigned to a particular user when the session is going on by the web server to identify that particular user. So suppose you log into your account, your Gmail account, your Facebook account, or your banking account, and I can get hold of your session ID. I can use this session ID, and using a tool like Burp Suite, I can log into your account without even knowing the password. So this is how dangerous a cross-site scripting attack can be. Now, I was just using the low security level. Let me just increase the security level and see what changes has to be done in this attack. So I'll just increase the level to medium. I'll click the reflected cross-site scripting attack again. Now let me give the same input. Let me give script, alert, and some string. And I'll just close the script tag. I'll hit the submit button. Now you can see that previously when the security was low, you saw a pop-up that said hello, but in this case, I don't see a pop-up. That means that this web application under medium security is doing something to avoid cross-site scripting. Now, how would you know what it's actually doing? Now look at the output. The input I gave was script, alert, hello, and I closed the script tag. So this was the input that I gave to the web application, and the output was only this. So this means that the web application is doing something to eliminate this script tag and the end script tag. So I'll just change my input to something like this. So I'll be using the same input, but I'll modify it a little. Because the web application is designed to remove the script tag, I'll just modify it a little. I'll just modify this code to look something like this. I'll add a nested script tag. First, let me give this as an input. Let's see if it works, and if it works, I'll tell you how this actually works and what's the logic behind this. So just copy paste this and let me hit the submit button. Now, like you can see, this actually worked. So when I use the nested script tag, it actually worked. Now let me explain how this actually worked. So like I told you, this web application is designed to eliminate the script tag. And when I give this as the input, what the web application did is it looked at the input, it found the script tag here, and it eliminated the script tag. And because I had nested a script tag, even when it eliminated the main script tag, there was another script tag that was formed. And this is how you could see the pop-up. So basically, when you nest a script tag, the script tag is eliminated. And when the script tag is eliminated, the divided part of the script tag is concatenated as a string, like you can see here. And then this code is executed. So this is how we can use cross-site scripting if the web application is designed to eliminate the script tag. Now let me just increase the security. I'll just increase it to high and hit the submit button. Then let me go to cross-site scripting reflected. Let me give the first input, that is the direct approach, and you don't see a pop-up. So it means that the web application is handling the cross-site scripting attack. Let me try the previous input. And even now you see the same output. Now let me just show you the code that is used to sanitize the input on this web application. So this is the code that is used to sanitize the input. So what's happening here is this code is making use of regular expression, and wherever there's a script tag found or wherever there's a script tag formed, it is replacing that with a blank space or with an empty character. So basically this means that we cannot use the script tag in any way. Now what other options do we have? So what you can do is give a malicious script or give a malicious input without using a script tag. Now what you can do is you can use other tags of HTML or PHP. I'll be using the image tag. I'll be mentioning the source to some random thing, and I'll be using this function called onMouseOver, and what the web page should do when the mouse is over that particular image. So this line basically tells there's an image, and the source to that image is this file, which is a dummy value in this case. And if the mouse is over that image, then create a pop-up that displays the string hello. Now let me just give this as the input and see if it works. I'll just hit the submit button. Okay, so now we can see that it says hello, but you didn't see a pop-up. And because we've given a function on mouse over, for the alert or for the pop-up to appear, you have to move your cursor on the image. So when I move the cursor on the image, you see that the pop-up appears. Now what you can do is, in this case, I've not given any image as a source, but what you can do is you can download an image that says click here, and instead of giving a dummy value, you can give the source to that image. So when you use that malicious code, what will be displayed is hello and the image that says click here. So when the user will go to that image to click on that image, basically because the mouse is over that image, you see a pop-up. So that's when your malicious code will be executed. So this is all about reflected cross-site scripting. Let's move on to the next type, that is stored cross-site scripting. So like you saw in reflected cross-site scripting, the data is not being stored on the web server. It is executed on the web browser. Now in stored cross-site scripting, what happens is the script is stored and executed on the server. So there are a lot of web applications like Facebook where you comment on a picture, where someone uploads a picture, you comment on a picture, or you post a status on your wall or on your timeline. So this data is stored in the database of the server. And every time somebody clicks on that page or tries to access that data, the web server fetches that data from the database and then displays it on the web browser. So when you're using stored cross-site scripting attack, you're basically storing this malicious script on the web server or the database that is being used by the web server. The advantage of stored cross-site scripting is, because it is stored on the web server, every time any user that is accessing that data will be executing the malicious code. Now let's see how you can use stored cross-site scripting to hack a web application. So this is a web page for stored cross-site scripting attack. There's a name and there's a message. So let me just give some input. I'll type test1 and the message will be message1, and I'll just hit the sign guestbook button. So basically this takes a name and it takes a message and then it stores that. So even if I refresh this, you can see that the data is still present because this is stored in the database and it is being fetched every time I access this web page. Now what I'm gonna do is try to inject some malicious code here. So I'll give the name as test2 and then I'll try the first input the direct approach and I'll hit the sign guestbook button. So you can see that there's a pop-up that appears. So this means that this web application is vulnerable to cross-site scripting attack. So even if I refresh this, you can see that it executes. The malicious script executes. So every time a user visits this web page, the malicious script executes. So it's the same in the case of applications that store data from the user. For example, like I told you about Facebook, when you post something, there's a comment, or when you post something on your timeline, you post a status on your timeline, and any other user or any other profile accesses that page to view your photos or to look at your status or the comments on any of the posts. They basically ask the web server to fetch that data, and that data is basically stored in a database. So in that case, any user who accesses that data executes that malicious script. Now let me just increase the security and see what changes we have to make or what security features have been implemented. And before trying the next injection, I'll just clear this guestbook, or else every time I refresh, the malicious code will be executed and I'll see the outputs, I'll see the pop-ups. So let me just clear the guestbook. Alright, so what I'm gonna do is gonna type the same input that I gave earlier. So that'll be test1 and the malicious script. Hit the guestbook button and see that it's not working. I don't see a pop-up here. So there's some way that this web application on a medium level is handling the malicious input. Now I'm gonna try to give the malicious input in the name field, but I'm not able to type a lot of characters. Let me see the message field. I'll just type message1 and I'm not able to type more characters. So this is because the text box is limited to take a limited number of characters. I'm gonna manipulate this by changing that restriction. So what I'm gonna do, I'm gonna inspect the web page, and here I can see that there's a line that says max length equal to 10, which means that this text box is designed to take only 10 characters as input. So what I'm gonna do is I'm gonna change this value to 100 and I'll just hit the enter button and close this window and now try to give the input. So because I've manipulated it, I've changed the max length of the input. I can give more characters as the input and let's see if it works. It still didn't work. That means even the name field is designed to sanitize the input. Now let me just modify the input. So I'm gonna nest the script tag, because here I can see that the script tags are being eliminated or they're being cut off. So if I find a way to manipulate the script tag like I showed you in reflected cross-site scripting, maybe I can execute this code. So what I'm gonna do is paste the script. I'll again have to change the max length. I'll change the max length to 100 and then give the input. And here I'll be using nested script tags similar to the way that I use in reflected cross-site scripting. I'll type a message here, message2, and let me see if this works. Well, it did work. And because I could see from the output that the web application was designed to eliminate the script tag, I just manipulated the way you inserted the script tag. I used the nested script tag and then I could execute the malicious code. Now let's move on to the next level of security, and before that I'll just clear the guestbook and I'll just increase the security. Go back to cross-site scripting stored. Now again I'm gonna try the previous input, the previous malicious script, and see if it works. I'll change the max length to 100 again. Give the nested script tag as the input and the message would be message1. Let's see if it works. Okay, it didn't work. And similar to how it was used in reflected cross-site scripting, I think this code is also using regular expressions to eliminate any script tags. But just to confirm, I'll just open the code for you and see if it's actually true. Yes, so it's same in this case. So what it's doing, it's basically identifying all the script tags using regular expressions and then replacing it with a blank space. So it basically means that you cannot use any script tags. So you need to use the alternative of the script tag. Now, similar to the previous case, like how we use in reflected cross-site scripting, I'm going to use the image tag for this. And before that, I'll change the max length field. And the input I'll be giving will be image source X on mouse over. I'll be creating a pop-up that says hello and some message here. I'll just hit the sign guestbook button. So now we can see that this worked, but the pop-up didn't appear because the function that I use is on mouse over. So let me see if I get the mouse over on the image. Yes, it did work. So when I brought the mouse over that image, you saw that the pop-up appeared. So this is how stored cross-site scripting can be hacked. Now let's move on to the next type of cross-site scripting attack, that is DOM cross-site scripting. So DOM basically stands for Document Object Model, and it is basically the way the website is designed. So when you use DOM cross-site scripting, it is a client-side attack. The script is not sent to the server, or it is not stored on the server. It stays on the client side. And the way this works is the web page sends a request to the server sends a response, the server script is executed first, and this is the genuine script that the server has to execute. So that is executed first, and then the malicious script is executed. So let's see how to use DOM cross-site scripting. So this is the web page that is vulnerable to DOM cross-site scripting. So there are different options here, there are different languages, and when I select one and hit the select button, nothing is seen on the web page, but you can see the URL is changed. So you can see that the default is set to English. Now let me change the value. I'll hit the select button. Let me change the language and hit the select button. So you can see that the language is being changed. So basically in this web page, I don't have a text box where I can give the input. Every manipulation that I have to do, or every script that I have to inject here, should be done in the URL. So what I'm going to do is I'm going to manipulate this. So instead of giving French, I'll use my malicious script here. So the script will be script alert hello, and I'll close the script tag. So when I executed it, you can see that the pop-up appeared. That means in DOM based cross-site scripting, you mainly manipulate the URL that is being used, or the URL that is being generated. So this is the low level. Let me increase the security. I'll change it to high. Let me give the same input again, script alert, the string is hello, and I'll close the script tag. Let me hit the enter button. Well, it didn't work. It actually went back to default as English. So let's see what's the code behind this, what's the logic behind this. So what's happening here is it's finding the script tag and it's just stripping the script tag and it's setting the default to English. So it means I cannot use the script tag. Now what if I use the nested script tag? Let me try that also. Let me nest the script tag like I did in the previous stages. Let me nest the script tag. Well, this also didn't work. So this web application under medium security is designed in such a way that if there's any script tag, it will set the default to English, the language to English. Now how can you bypass this? For this, I'm going to inspect the element. So let me see how the web page is displaying all this data. Here you can see there's a form tag and there are different options here. So I'm going to make use of this syntax to inject my malicious query. I'll just copy paste this. So this is a line that displays English as the value. So what I'm going to do is manipulate this. So the way this is designed is there's a select tag, and under this there are different options. English. I'm not typing the whole code because I want you to understand the logic, and other inputs, and then the select tag is closed. And when one of the option is selected, maybe English, so this option is selected. If I choose any different option, maybe French, then this line is selected, and so on. So what I'm going to do is manipulate the URL in such a way that the option tags is closed earlier. So basically when I choose English as the default, it says English default. So this part of the code is executed and this is used to close. But instead of letting the page do it, I'll give that as the input in the URL. So what I'm going to do in the URL is I'm going to close the tag right here, the option tag and the select tag, and I'm going to use the body tag here and the function onload, which has to create a pop-up that says hello. Let me hit the enter button. Now, as you can see here, I could successfully inject the malicious code in the URL. So how this works is, so when I choose English as the option, this part is executed. So instead of the web page closing this for me, I'm adding another option tag and I'm adding another select tag. So what happens is this part of the code does not execute because I'm closing it here and then I'm typing my malicious script here. And that's how this code successfully executed for medium security level. Now let me increase the security level to high and see how it works. Let me try the direct approach. Well, this didn't work. Let me use the previous approach. Well, this also didn't work. So the web page is designed to sanitize the URL. So let me see the code for this. So this code is designed in such a way that it only takes these languages as the input, and if there's anything else apart from these languages, it will set the default to English. Now, how to approach this? So to hack this, you need a little idea about how web pages are designed. There's something called an anchor tag. So anchor tags are basically used to index a particular part of the web page. Let me show you an example. So I'll open a blog that uses the anchor tag and then explain you how this works. So here you can see the URL that says edureka.co blog and the URL of the blog. And if you scroll down a little, as usual, there are different contents on the web page. And what I want you to see is the index part. So there are different topics that are covered in this blog, and here's a list of it. So what happens when I click on one of this is the web page takes me to that particular part of the web page. So in case I click this, it takes me to how to use network scanning tool. And in case I click on types of network scanning, it'll take me to that part of the web page. Now what I want you to observe is whenever I click on one of the anchor tags, the URL is regenerated to point me to that particular section of the web page. I'm going to make use of this feature of web design or web development to hack our web application. So what I'm going to do is I'm going to use a pound symbol or the hash symbol and then use my malicious script after that. So because the pound symbol is used to index or to point to a certain page on the same website, this web page will not consider it as the input. It will just think that we are trying to point to a particular part in the web page. So let me type hello and then close the script tag. Let me hit the enter button and see if this actually works. Well, it did work. So you can see that there's a pop-up that says hello, and this is how you can use a pound sign or the internal anchor feature of the blogs to inject the malicious code. So this is all about cross-site scripting attack. We saw three types of cross-site scripting, that is reflected, stored, and DOM. And what type of cross-site scripting attack you use depends on how the web page is designed. You cannot use DOM cross-site scripting on a web page that is vulnerable to stored cross-site scripting. So first you have to understand how the web page works, how the web application works, and then decide which type of cross-site scripting attack to use. Now let's move on to the next topic, that is how to prevent cross-site scripting attacks. So the first thing you can do is escape the user input. So there are special characters like greater than symbol, smaller than symbol, which are generally used in tags or in malicious script, or maybe the percentage symbol. So the first thing you can do is escaping these characters, which means that you take off the special feature of this character and make it just another text character. The next thing you can do is consider all input as a threat. Because the user has complete control on what input he gives, you have to assume that every input is a thread and sanitize and handle every input with care. The next thing you can do is data validation. Suppose you have a field of login where you can enter username and password. What you can do is use data validation, especially in case of email IDs, because you know the generic format for an email ID. There should be a username, there should be a @ symbol, then something, then .com or .something. So you can use data validation to avoid cross-site scripting attacks. Next thing you have to do is sanitize the data. Like you saw in the demo that some of the web pages were sanitizing data they were eliminating the script tags, or they were eliminating any script tag found, and they were also using regular expressions to eliminate all the script tags that can be generated. So this is how you can sanitize data, the input data. Next thing you can do is encode the output. So what happens is, when I gave the script tag and alert as the input as the malicious script, the arrow symbols were being treated as the arrow symbols. What you can do is you can URL encode them. So the arrow symbol will be something like %25. So when you encode it, it's no longer a malicious script. So you can use encoding, URL encoding, for the input or for the output. Next thing you can do is use the right response headers. You can decide what the response headers should be. You can decide what data can be sent or what data can be received through the response headers. And finally, what you can do is use content security policies. So this is a standard. It is also known as CSP standard. So you can use a content security policy to avoid cross-site scripting. To know more about this, you can just Google it. You can just Google content security policy to know what standards are this. So that's it for today's session. If you like this video, like and share, and stay tuned for more videos on ethical hacking, where I'll be talking about different hacking techniques. Until next time then, bye bye.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!